Hello, Internet! Last time, right here on Devcom Tutorials, we created an actor and made it move with our C++ code and a bit of blueprint help. Today, we're gonna make it move based on player input and at first some blueprint help, so just we get things started. And then we'll create a player pawn or player pawn actor solely with pure C++. No blueprint helping whatsoever. So let's get started, shall we? Yes, and here we are. Hello again, everybody who's already tuned in. I see Ref, Road Pest, and Lakeside, and or a wonderful evening to all of you amazing people out there. And thanks for tuning back in for episode 2 of an ongoing series of Devcom Tutorials, where we talk about coding for Unreal Engine, which is the first quite amazing thing, in C++, which is the second one, because both are pretty cool. And yes, hi everybody. So in a moment, I will skim over what we did last time, but I won't go into too much detail. If you missed things and you're like, okay, it's pretty cool that you do that, but how, and more especially, why did you do it like that? There is, and I think I should have a link to this, and I might even shamelessly drop this into the chat, because we, of course, got a recording of last week's session. It's available on YouTube for everyone to watch, everyone who wants to keep up, who maybe missed something or wants to re-watch something. Also, but we're going to see that when I switch over to the scene where you can actually see my screen, I want to introduce a hashtag that you can use on Twitter. If you have any questions, you would like to have answered during the course of this series, or maybe just directly on Twitter, if it really doesn't fit the topics we're covering here, then feel free to tweet at hashtag AskDevComTutorials. Well, you will see on this side. On this side, there's these little ribbon thingies that state very important things. And once I switch over to this view, where you can actually see what's going on and happening, there is also about, let me see. Okay, now it's above me. Okay, now I can't point to this. So now it's above me. That's the hashtag. Feel free to use it if you have any questions. If there's things that were unclear or unanswered or anything else, just tweet at that and we'll see that we get it covered and answered. I will also check the comments on the YouTube videos. So if you're watching this on YouTube, feel free to just use the comments down there to ask whatever you like to ask. And I will check these, I don't know, maybe not every day, maybe not every other day, maybe once or twice a week. I will take a look at those comments if there are any, and if there are, either directly answer them or see that we get them covered right here. So let's dive into it and let's see, what did we do last week? As said, just skimming over it, not going into too much detail, because for all the detail we have last week's video, so we don't need to repeat all that. Just a quick rundown of where we're at, what our current situation is, so that we can then pick up and make things more worky, to make them do more work. Is Ask Devcom Tutorial correct or with an S at the end? Sorry, whatever I've put there, I can't actually, can I see it? My preview is so small I can't really see it. Whatever's written up there, if it says Devcom Tutorial up there, and I just said Devcom Tutorials, whatever I put up there is the correct thing. Use that, or I will maybe I will just search for both. So either way, I think I will search for both regardless. So whichever you use, I will try to make sure to find it. If I don't find it, or you find yourself ignored because the question wasn't answered, also now if you see now it's below me, it's a bit below me. You also see the two Twitter handles. One is my personal, the Real Hellcat is my personal Twitter handle, and Spaceflower DE because it's a German, and I think the other Spaceflower was already taken or something. And Spaceflower is the Twitter handle of our studio. Also, feel free to tweet at those if you like. So that's also perfectly fine. Or, I don't know, for any other reasons you might think it's super important that you tweet at me. Do it! It's Twitter. It's an open world, and you can pretty much tweet whatever you want. If you get a reply, that's a whole lot of a different story. All right, so let's see. We had an actor built. We got this very, very neat sitting cube here. Very detailed model with all these edges and the sides and everything, and 6 of them actually. Even though if you would run around, you could only see 5 because the other one is just sitting on. But okay, and we made this thing move. And eventually you will see, yeah, there it is. There it is. And we can see it moving. It moves and moves and moves. And I think we also made it so that we have some values here that we can change. Like we could say you also move on the y-axis, compile and save, hit play, and something. Oh yeah, and there it goes. See, it moves to a completely different direction. And even though this is inside a blueprint, we're calling set movement. And this set movement, that was C++ code that we've written, which is, no, it's not that one. It's only this. No, it's also not this one. It's that one, set movement. Ah, look at that. Whoever can read is clearly advantageous. Here's our set movement function that we set up to be able to be called from a blueprint. And remember, we did that just by decorating it with a U function blueprint callable, which tells Unreal, okay, while it compiles our code, okay, this function is supposed to be able to be called from a blueprint. So where is it? Here. This node, this blueprint node, actually is a call to our C++ function set movement right here. We don't do much. We just take the x and the y value, put it in our movement vector, and then also in our C++ code, we have this block where we do the actual moving of our actor into the direction that we had given here. This is called every frame from this tick component function, because this one is called by Unreal every frame unless you disable it. For performance reasons, you can disable that, and I should somehow get my chat back so I can see if something very important happens. Hello to everyone who just joined in. And yeah, this tick component is called every frame unless you disable it. And inside the tick component, we call our move function that then takes care about moving that thing to wherever we want to have it. Anything else that was like super important? We discussed a bit that in C++ we have 2 files actually for each piece of code we write. We have our C++, our .cpp file, where like this our actual code is in, and then we also got a header file which defines, which has lots of definitions and information about our code and the functions that are inside the code. Yeah, it's a bit covered. We covered it a bit last week. Just if you need to brush up on that, there's the video, and we will be coming to back. I promised you last week we will be coming to back to this and talking a bit more about how these header files work when we talk about pointers. Because that, I also promised you we're going to be doing that, and this is still a tiny little bit in the future. Not exactly sure yet when we're going to do that. Maybe around part 4 or 5-ish, give or take a few. I think we will take a whole evening talking about pointers, why they are, how they are, and while you can lose quite some hair about them. Yes. So, anything else? We did one more thing. We did this do something with numbers, which is a completely useless function. I just showed you that when you set up a C++ function that you can call from your blueprint, sometimes you want to do it something and give you the result back, and because you want to do something with that result. And we showed, or we took a look at how we do that. This is this function with those two, A and B, being the inputs. These two nodes where you can just give the function its parameters just like you usually do. And then you can see in the blueprint node, here we have 3 return values. We have a return A, B, and C, which is these 3 guys. And either you remembered or the keen-eyed of you just noticed we have this ampersand signs between the type definition of what kind of type our value is and the value name itself, which basically tells the compiler, look, we are not getting a value here, we're getting the address of the value. Again, I explained this a bit last week, and we will come back to this when talking about pointers, because this is basically a pointer you're getting passed. So we are able to manipulate variables or values that are not inside our scope, that are someplace else. So this is the mechanic used to give these values back into blueprints. So for the moment, if you didn't quite understand yet how this works, how this passing values by reference and having them changed from the call function and everything, there's a very simple thing you just need to remember. If you want it to be an input, you just stated what type it is. If you want it to be an output back to the blueprint, you just put this ampersand sign between. And it's also, it doesn't matter if you write it like this or if there's 2 spaces surrounding it. Maybe you should set the font size. See, this is when you use the same program for demonstration purposes like this. And for your daily work, you tend to set up the huge font so you can actually get some code on your screen. Because there's a saying like when the code of one of such a function is more than, and this is also the reason why coders tend to use very, very, very tiny font sizes, because it's best practice or good practice when you say once the code of one function doesn't fit on one screen, it's too big. Split it up into multiple separate smaller functions. So that's why most coders use a very, very, very tiny font size, because the smaller the font, the more stuff fits on one screen page. Also, this is why most coders want to have 4K screens, so even more stuff that's fitting on one screen page, and you don't have to break up your code into multiple smaller functions. I'm not sure if we ever get to a point like this during the course of this series. Maybe we do, or maybe we just construct one and try to break up things. So these ampersand signs, I think now you can see them quite better. It doesn't matter if you write it like so, if you put it immediately on the back of the type, or if you have it completely surrounded by spaces, or if you slap it directly in front of the name. It doesn't matter. I'm not sure if that works. Well, okay, according to my IDE, even this works. So the thing is, between your type and the name of your value, you just put the ampersand, and where you put spaces and how much spaces you put there absolutely doesn't matter. This will be an output back to the blueprint. So you can do something inside your function and let your blueprint know about the result, because maybe you want to do things with it, or yeah, well, the sky is the limit basically. So yeah, just remember that, because you're using them, the usage inside your function does not differ. So you can see when I access A and B, or if I access return A and return B and return C, that would be here if you could see it, there's no special treatment. There's no special treatment. I use them pretty much the very same way like those. So if you haven't grasped it quite yet, just remember the ampersand for return values. And later on, we will take about pointers and exactly see why and how all this works under the hood. So yeah, and this was just, we can basically completely ignore this. We just fiddled a bit blueprint stuff together so we could actually see our the stuff we return. We put 1 and 2 in here, and what did we do? Return A is the sum of those two, B is it doubled, and C is it tripled. So we should be able, if we run this now, it's still printed up there, but I think it's pretty tiny, so I try to magnify it a bit. We can still see the 3, the 6, and the 9. I'm not exactly sure what. Oh, and now it's gone. Okay. So we run play again, and here we got the 3, the 6, and the 9, and over there is our cube running away. So that's a quick rundown of what we did last week. Now let's talk. No, one more thing. One more thing, just as a reminder, how we got our code to work on our actor in the first place. Because our actor is a blueprint, right? When I click here on this thingy, this little colorful clicky thingy goes open. I can put my blueprint nodes, and of course we're not here to do blueprints. We just use them as an example, or to first get an idea what we're supposed to do, what we want to do later in our C++ code. So we have a plan, what you need to do, and then later on we can actually do it. We've written our code as a component, an actor, a so-called actor component, which means, and this is for you guys that know Unity already a bit. In Unity, you already also have your components. And you have your game objects, which in Unreal are the actors. Everything in Unreal is an actor as much as in Unity. Everything is basically at the root of it a game object. And we have here our components list. And we just said add component and added our component that contains our C++ code just to it. We can pull it onto the blueprint stage, and then we can pull out this little wire there, and then we got the option for call function. Let me magnify that a bit. And then we got our call function, where we have all the functions available to call that we declared as we want this to be callable by a blueprint. Because if we do not, let me delete this again quickly. Because if we do not do this declaration, if we do not put this U function and blueprint callable in front of our function, it won't be callable. So I don't know, for example, and this will completely break it. This will completely destroy it. Let's remove it. Let's save it. And let the compiler have a quick run at it. And also the autosave. There's no sound, which is sad because I kind of like these Star Trek-like sounds when you compile. And it's still compiling. This is, yeah, see, that's the sound I was talking about. So if you now go back into the actor and we need to, I think I need to restart the editor for it to reload everything. But now already when I say refresh node, it already completely deletes, might do something with numbers and there's nothing left there. I'm not sure if, yeah, and also, okay, for a change, the hot reload worked. See, this blue wire is coming from the reference to our moving component. And when I pull out another wire and I go to the call function, my do something with numbers is completely gone. Because I removed the U function blueprint callable decoration. So now this thing is supposed to be called from any other C++ function only, which is not a problem because actually we don't need all this stuff anymore. This was just to show how you can actually pass return values back to the blueprint. Now we're gonna be trying, because our actor only moves in a set direction. We got we can, like, I don't know, let's put 0.5 here so it looks a bit different, and for some reason it doesn't like my 0.5. Compile and save. And there it goes. So, but at the moment it just moves at a fixed direction and it moves there indefinitely and it never changes and it never does anything else, which is sometimes not the thing you want. Sometimes you want the player to be able to control your actor. So we're going to be deleting this, and I think we also just be dropping this one. I think we can recycle our component because our component still has our set movement and it also takes care about the actual movement already. So what we're going to do now is, at first we take a look inside the blueprint how we make this thing player controllable, because there's something else we need to talk about, how you get an actor being controllable by a player. Again, going a bit into Unreal basics here that don't have to do anything with the actual code, no matter if it's Blueprint or C++ now, because I have no idea how much you guys know already about Unreal. So I've said this before, if you're already super pro in Unreal and you know how things work, you only want to know how the C++ stuff works, just let me know. And I will change the style of things I do. But for now, I'll just consider you have absolutely no idea what's going on. So I will keep explaining these things until you beg me to stop. To have an actor, and again, an actor is everything that lives in your scene. Everything, no matter what it is. If it's this floor tile, or if it's a static mesh like this table, or this chair, or if it's the player start, where the player begins his journey in your great life, or maybe even just the light. They are all actors. They all based are on a base actor class that has very basic functionality to make these things work and live. There's some noise sitting there somewhere. To make these things live and exist inside your game world. And then there is special extensions of those. So for now, just to take a look at what we have to do, just so we know what we're actually doing when we start doing it in C++, we take a look at how these things work, what we're going to do in a blueprint, because it's a bit more understandable and visible what's actually happening, what we're going to do, before we then dive deep down the rabbit hole, drop any blueprinting, and start completely over and do really everything. And this is something we're definitely going to do this tonight. Definitely going to make this thing here a pawn actor completely in C++. But first, let's see what we need to do in the first place. A pawn let's see what the little description tells us. A pawn is an actor that can be possessed and receive input from a controller. First thing is, with controller, they are not talking about the thing you're holding in your hands with the little buttons and the analog sticks. They are actually talking about like our component is a piece of code, there's pieces of code that are called controllers. And there's a player controller. And this player controller, the name's the deal, controls all the things the player does. For now, this isn't much. We're be using the default player controller for now, so we're not bothering with this. But I will think up some samples, some examples what we can do with a custom player controller. So we're going to be covering this later down the road, just not today. So a pawn is basically an extension of an actor. It's an actor with extra stuff added to it. So it can do things the normal actor can't. The normal actor could be moved by code, but the pawn can be possessed. That means a player can take over and can take control of this pawn, and the pawn can then receive input from the player. This is some of the special sauce that's added to an actor to make it a pawn, because all these things a normal actor can't do. But the pawn can, because there's a base class that already has these things added for us. So we're going to be calling this our first pawn. For those of you, oh yeah, and also I was about to say, for those of you who play a lot of chess, you know pawns, and I don't think it's a coincidence that the icon of a blueprint that's derived from a pawn, from the base pawn class, actually has a chess pawn there as its icon. So we open that up, make everything neat and tidy, and of course we need to have it to look like something. So the first thing we're gonna add is a static mesh component. This is default. This comes with Unreal. We just need that. And we had our cube. Let's take the cube CUDA. Okay, maybe I will learn writing cube someday. So there's our cube. So now our pawn actually looks like something, like a quite neat little cube. So let's go into the event graph already. And let's add our movement component. There's our moving component. The naming, I noticed this last week already. The naming is a bit off. We call this, or I called this moving component. A better name would have been movement control component. But then again, when you do this at home or later on in your own projects, you're completely up to your own naming. So don't blame me if you call it moving component and then got confused, because that's a weird name. In your own projects, you can give it actually a decent name. So let's recreate what we had so far. We had our set movement, and this is where things become interesting. Here we set the movement where our pawn, or that thing that represents our player, where that thing's supposed to be moving. And I need to peek a tiny little bit into my own notes, because there's one more thing we need. We actually need a camera, because that's one of the specialties of a player pawn, because the player pawn also contains, or can contain, you can switch it, but the player pawn usually also contains the camera from which the actual player, the 8th layer sitting in front of the screen and actually playing the game, sees the game. So the placement of the camera is, as you know, what makes it a third person, a first person, a top-down person, or whatever game. So we also need to have a camera. And this is all things, you can brace yourself, this is all things we need to do manually by hand, line for line, when we're doing this in C++. Because right now, this is like super easy. We're just, oh well, we're adding a static mesh. In this case, it's a cube. Oh well, we're adding a camera, and I move it a bit like there, a bit here, and then I see that those values actually match up. And maybe at least one of those direction is the wrong direction, and then I give it a nice 45, not even able to type numbers properly, a nice 45-degree angle, so it actually looks down at our pawn. And let me peek into the chat if there's anything. Nope. Okay. And this is pretty convenient. And last week I said that usually when I work on actual projects in Unreal Engine, the way I do it is actually this way. I create the basic actor as a blueprint and put all the things in there that are supposed to be there. And then from the event graph, I call all my C++ code that I have slapped onto the actor or the pawn as a component, just like we did with the move component. And I think by the end of tonight, you will understand why this is the way I prefer, but this is only personal preference. Mileage may vary for you. You may have completely different opinions on this and be like, no, I want to do everything in C++. This is cool. This is the way I roll. This comes absolutely down to personal preference. So yeah, but this is my preference, that I do it pretty much like this. I set things up with the blueprint as a base and then just call my stuff that's in my C++ component from the blueprint. Because it makes things just so much more easy. So now we do have a camera, so we can actually neatly see. And I need where's all right, okay, just let me check the chat for a second, but it's everything's safe in there. That's good. So we got our set movement, and we don't want the pawn to just move into a fixed direction. We want it to be controllable by the player. And here there's a thing we need to do. That's a prerequisite for this. There's one thing we have to do before we can properly have this stuff set by our player. And this doesn't matter if you're doing it later in C++, because we'll be using the same thing or be referencing the very same thing later when we do our C++ code. You need to set up your actions and your axes. And for that, we go into project settings. And here they are. And we go into, let me find it, input. Because right now we have no controlling scheme configured. Oops, that was the wrong button. I just want to have my chat back. So we don't have any controlling scheme configured. So the game or the engine doesn't know to what input it should react at all. So we first need to define this. So you can have action mappings. Action mappings are things like shooting, jumping, blinking with your eyes, or whatever you do with your character. And axis mappings are, yeah, well, pretty much exactly that. We can define as many axes as we want, however makes sense. In this case, we want two of them. We want a horizontal axis, horizontal, and I think this is, in the stream, this might be so tiny that you can't see it if I mistype it, so that's perfectly fine. Mistype away, no one will ever see. And we need a vertical And we need, for each of these axes, we need 2 inputs. So we add just another one for each of them, because we need one in the one direction and one in the other direction. If you have the horizontal axis, you can go either to the left, which from my perspective now is the right, but I hope from your perspective, it's the left. Well, whatever. You can go to the left or you can go to the right. And we have to define what actual input we want. Like we, and this is very, very, very nice because you can set up different things here. We can give inputs from the gamepad, like if you want your game to be controllable using a controller or keyboard. We could say, yeah, look, we have gamepad left thumbstick, x-axis is our horizontal, which I think might even be right. And for now, since I don't have a gamepad attached at the moment, for now we're just going to be using the keyboard. So for left and right, I'll be using A and D, because that's always a good choice. That is always a good choice to do things. A and D. That's good. And then you have to set a scale, because the one moves in the one direction and the other moves into the other direction. And this is, I always have to try this out. I just say, I don't know, let's say D is -1 or -1, whatever you like more. So D is -1. We might have to switch these around. Same goes for the vertical. But maybe I hit the right one. So for vertical, I be going with I and B. No, kidding. I'm going with W and S, of course. I think most of you saw that one coming. So W for up, and I think it might be positive. I don't know. We're going to see. And we'll be using the S key. There it is for down. So that's -1. So here you can set up your input like whatever you want. You, as I already said, you can add for controller or for I don't know what else do we have? We have gamepad, keyboard, mouse, motion, touch gesture, whatever. Steam, Android, lots of special things. If you need something to read before going to bed, you could take a look at the whole list of what options you have and then just decide which ones you like more. So you can also do, as you just saw, there is special things like for PS4, because the PS4 has buttons no one else has. Steam has some special things that nobody else has. And you got them all covered. You can use whatever you want. Like has Android back, Android menu buttons, volume up, volume down, things that are also usually not available on things like a PC or something. So, this is going to be very important if you want to make a multi-platform game that you, I don't know, maybe you want to actually publish it on PC, console, and mobile. All of them. All in. Then you can set up your things here. So we set up our horizontal and vertical axes, and we will see if they're right. So now we can access them. Now we can actually try a get axis value. Oh, there they are. Look at that. Look at that. How convenient. Input, axis values, horizontal, vertical. These are the 2 axes we just defined. So we're just gonna pull out the horizontal one. And just for good taste, the vertical one as well. And we could basically just feed those directly into our movement, our set movement function. But we can't do it at begin play, because if we do it at begin play, it sets the state how they are just when we started the game. But we want to do this continuously, so there is this tick function, which we also have in our, this is the component, in this case it's component tick because our C++ code is a component, and here it is, tick component. So everything, really everything, every component, every actor, everything, every, like these things that you write, no matter if it's in blueprints or in C++, you always got such a tick function. And then we can just, you know what, we make it a bit clean. We set it to 0 when we start off, and then we copy paste this down to here. Let's tidy this up a bit. So horizontal, I hope is X. Sometimes the axis gets swapped. We'll see. Maybe we need to swap them out and have them run on our tick. I'm not using delta seconds here because our component, when our component is actually taken, because this is only setting the direction. This is only setting the direction. The axes go from -1 to +1. And remember when last week we set up our movement here, we also said, okay, we only, our direction vector will only be between -1 and +1, because this is only the direction, not any speed or the likes. So we're basically just feeding whatever the axis value is, because we set the scale from -1 to +1. I think you can put in any numbers you want. We could basically have it from -13 to +33. If that makes any sense in any situation and you feel like you need to do that, I think you can, but usually it's just from -1 to +1, and then you map these and multiply things around to get the actual end result you want. So we don't need the delta seconds here because we are only setting the general direction in which we want to move. And our actual move function in our C++ code, that has a delta time, and that also multiplies the delta time into it, so we are not frame rate dependent. Remember, the delta time was important, because if we don't use this, if we just go, okay, we multiply our movement vector by our speed and be done. If we do it like so, we'd have a game that would be frame rate dependent. So on a computer that plays the game in a higher frame rate, your actor moves faster. And on a computer with a slower frame rate, it moves slower, because it does these things fewer times per second. And to mitigate this, we're having this delta time. The delta time is the time since the last frame. So this is the time between two frames have been processed, rendered, and displayed. So you can scale this down. So you have basically our movement speed is units per second because of this. And if you're running with 10 frames per second, because you really have some kind of potato computer, or you're running with 240 frames in 4K because you got a rocket booster as a computer, doesn't matter. Your actor always moves the same speed. So yeah, this was the delta time, and our actual move function takes care of this. We just need the direction to be set. So this might be it already. There's just one thing that's missing. We'll just do that. I don't pretend like, oh, we got an error, it doesn't work, let's find out why. We have to let our pawn know that it wants to receive input from the player. Because, of course, the player can only, well, usually, the player can only be controlling one thing at a time. So we have this pawn to be possessed by the player, and I don't think we need to manually explicitly enable to get input. I think we're doing this automatically once we possess the player. So there's a very neat And I hope, oh yeah, no, those are the events. Let me see if I, look at that. Here it is, possess. Handles attaching this controller to the specified pawn only runs on the network authority. Okay, this is then for network gaming. This is the possess function. This is a Unreal supplied function that takes care for the given player controller to possess the given pawn we feed in here. We don't have a custom player controller now, and even if we would, the process would be pretty much the same. We also have a function get player controller, this one, and then we can tell it for which player. And since at the moment we only have one player, and you know computers start counting from 0, it's the player controller for player 0, and we put this into the target thingy there. And then we need the pawn, which is our self. So maybe we have a self. Do we have a self? Get a reference to self. Look at that. How neat. And C, we'll think we're going to just be writing this. So again, we're only doing this in Blueprint right now to a bit more understandable show what we are doing when we're writing our C++ code, which we will dive into a few minutes. This is just a small outline, so that those of you who don't know perfectly how Unreal works and how you do things in Unreal, who don't know what we need to do, so you understand and get a grasp of what are the things that we need to do. Because let me know if I'm seeing this wrong, but I think if we would just dive into the C++ code, and you'd have to understand the C++ itself, and then what the hell are we doing here? I don't know, might be a bit too much. So, but let me know if this is actually too detailed, if you don't need this. So then we're going to change this. But so far, everyone seems to be happy, so I'm just going to do it that way. And I think, if I'm not completely wrong, we now should be able to control this pawn using our keyboard. So first we have to place it somewhere in the scene. I don't know, let's just place it there. And there it is. And look at that! Things are happening. You can't see my keyboard, so I could just say, yeah, everything's perfect. But horizontal and vertical are actually... that's a cute ball there. Why is that there? I have no idea why that white sphere is there. Oh, that might be... No, might not. I don't know. What is this? Let me see. What is this? This weird sphere here. What is that? Oh, that's the default pawn. Okay, this is... okay. We actually have 2 player pawns in play at the moment. We have the default player pawn, which is this one. And we have the one we just added to our scene. Because because you see this thing where the actual controller is and the flag and this capsule thing, this is the player start. This is where the player begins his play. So we just delete this. Because when you hit play or when you start your level, the engine places a default player pawn at the player start, where the player is supposed to begin the game. So instead of just instead of just moving our pawn somewhere and saying, okay, this is our pawn, our player will be starting to play with this, we can just tell the engine that this is our player pawn. This is the thing our player is supposed to be playing with. And then we don't need to put it into the scene, because the engine will take care of spawning it where it's supposed to be, and then we can take control. But before we do that, we just we just do it the lazy way. We just don't cross the streams. Blueprints have a right to be nice and tidy as well. So we put the vertical into the X and the horizontal into the Y. And for now, we're just going to be living with that. I'm not even sure if now I maybe need to swap the negative and the positive one, but we're going to see that. First we go into, and now I actually have, where do we set that? I think it's the world, it's either the project settings or the world settings. I think you can put it into both. Maps and modes. Do we have a default player pawn? No, so it's then it's in the world settings. These are the things I always need to look up and to see where it is, because I don't do these so often. We just do it once and then we have our pawn set. Project, where's the world settings? See, this is the things where my math teacher back then always told me you don't need to know everything. You just have to know where to look it up. And now I need to look up where I find... Oh, world settings. Yeah, there they are. And we actually game mode overrides. Player controller, this is looking promising. Default player pawn class. Game mode overrides. Oh, we actually need to put it into the game mode. Why can't I just put something else in here? Use selected asset from the content browser. That would be this one. Can I just drop this in there? I actually... Okay, it doesn't let me. For whatever reason, it's not letting me set the overrides here. We could go all in and make our own game mode. We could perfectly do that, but I would rather not. I would like it a bit more if we could. Oh, wait, maybe we should. Is it saved? Yeah, we did save it, right? Save all. Well, okay. For now, we're just gonna be living with that. We can control it. And yes, directions for A and D are... So this is the one thing I didn't try out before starting tonight. The other things I did try out. This is the one thing I didn't try out. And as you can see, better should have done that. So, project settings, input... where is it? There we have it. And then we just say A is -1 and D is +1. And I think now... Yes, now I'm actually moving into the directions I am hitting my keys. So, these are the things that are required. It's a bit slow, but then we made this settable from the editor. Remember, we had our movement speed somewhere here defined, or maybe we didn't. Yeah, we did. Here it is. Here's our movement speed, which is currently set to 100 units per second. And we also said, okay, this is an Unreal property, so we're not using this solely in C++. We want this to be globally known, and we want it to be editable anywhere. So we could just go to our, you know what, make this a bit bigger. Here's our moving component, and here's our movement speed. We could just set that up to 250 or something. Compile and save. Yeah, see? And now we're clipping neatly through these chairs, but we're doing it with a bit more speed, and we can even go diagonal. Okay, so this is what we need to do. This is what we want to do now. We want to get the player controller. We want this player controller to possess our player pawn, so that we can then react to the input and have everything moving around like, yeah, it's supposed to be, to get the axis values and to set them and move, like to move it. And now, as we know what we're going to do, we're going to be doing this. Finally, this is the moment you've all been waiting for. We're doing this in C++. And then you see that this is quite a bit more work. So let's close this one up and delete it from here. Let's go into our C++ classes. And let's add a new C++ class. And just as we did with our blueprint player pawn, we also have a pawn class we can be inheriting from when we create a new C++ class. So we're going to do that. We're going to be making a pawn. And we're calling this our C++ pawn. And we're going to be putting this... Oh, let's just for the sake of doing it, let's put this into a pawns folder. So create class. This will take a while. And in the meanwhile, I will... There's my notes. My notedy notes. Now I need to see if I get my notes and the chat at the same time, because that would be lovely, wouldn't it? Yeah, I think this will work. I think this will just work. Oh. Okay, I think it opened. Okay, for some reason it opened the C++ class in the wrong editor. Let me see if I can get this opened in the right one. This looks better because now you can see something. So, no, yes, here we are. This is our C++ pawn, and there's, again, we need to tidy it up a bit. There's a lot of comments that are always the same. So let's just clean them up a bit. But see what we got there. First, let's check out the header file. These are default includes that we all need. And you can see we're extending the A pawn class. Again, Unreal prefixes everything with what it actually is. So the pawn is a special type of actor. So this is why it's prefixed with A, because it's an actor pawn. We're ourselves, our C++ pawn is therefore also an actor, so it also automatically got prefixed with the little a there. And we got something that's public. We got our constructor, set default variable with pawn properties. Okay, now we know that. Let's tidy this up a bit. And again, we got two public blocks. You might just not care, and yeah, well, let it be like that. I do care, so I snip this away and put it up there, and we can drop this public block. Well, I don't need two public blocks. One is enough. So here's our tick function. And also note, this is also only called tick. In our component, it was called, let's take the header file, it was called tick component. I have no idea why they make a distinction between those. It's basically called every frame. It's the same thing. Maybe the parameters are... Well, yeah, the parameters are a bit different. So maybe it's because the component tick function, you see, it gets a few additional things passed that you can use to process. And our tick function that's just called tick in our actor only gets the delta time. So again, the time since the last frame, so we can make this completely frame rate independent. So now we know that. Can we delete this comment? Call to bind functionality to input. This is very important. We are absolutely going to use, and we need to use this one. This is very important because you can already see with the default comment, use to bind functionality to input. If we want to process the input we're getting from the player controller, and therefore the player, we need to do something in here to actually process this input and make it do something. So, and this is our begin play, called when the game starts or when spawned. So this is not only called when the game starts, but if you have a pawn that's gonna be spawned later in the game, because, well, a pawn doesn't have to be controlled by a player. A pawn can also be controlled by, I don't want to call it an AI, because it's not an AI. It's just a few ifs and stuff that does things. But if you have code, like you have enemies, you have monsters. You're the hero, you're running around, and there's monsters spawning. These monsters are also pawns, and they move, and they attack, and they do things. But the things they do, the input they get, they don't get their input from an actual human player. They get input from some other code you wrote. But they are also a pawn. So the begin play is also called when your pawn has just been spawned. So there's the world's going on for hours. The player is doing really good and did 60 levels already this night. And then your monster spawns. It's a new pawn that spawns in the game. And well, not the very first thing, but one of the first things that happens before the pawn then actually starts doing whatever it does is this begin play function. So we got two places, and this is a very important distinction we have to take. We have two places where we can put code into that's being executed at the beginning of the lifetime of our object. In this case, our pawn. We got our begin play. That is called when the game is started or the actors spawned. So when you just drop your pawn into the editor, if you just put it into the scene somewhere where you want it to be, the code that's in begin play is not executed because begin play isn't fired. I just lost my notes again. Come on, where are they? They are not fired because the game hasn't started yet. Technically, your pawn is spawned already because it's sitting in the scene. It's sitting there for the game to begin, but the game hasn't begun yet. So this one isn't called. This is then called when the game is started. So you can set up things that are super important like you need. And then we got our constructor. This one, the begin play, is an Unreal mechanism. That is something Unreal does. Unreal takes care about begin play being called when the game starts or your actor is, or your pawn is spawned. So Unreal is calling this from your code. This one, this is the class constructor. And this is a language construct. That's not only this is not a special C++ thing. If you've already done C# for Unity or Java for whatever reason, or even PHP, you can have a constructor for your class. And this one is called when your class is instantiated. So when your class is actually being used and it's initialized, and an object is a usable object is created out of your class, so that other code can then do stuff with your object, can call functions from it or whatever. The constructor is called before anything else happens. So this is actually the very first thing, the constructor. Or if we go back into the header file, we can see it a bit better. The constructor is the thing that's called or that's executed during the creation of the object that's based on your class. I don't know. Do we need to talk about classes and objects and instantiation? Let me know in the comments if you're watching this on YouTube. Let me know in the chat if you're watching this right now. So this thing's called. So when some other code creates a usable object based on your class, this code will not continue before the code in your constructor has been executed. So this is very, very first time stuff that you can use to initialize internal values, the state of your object, or whatever you need to do, so your object is actually able to do whatever it needs to be done. You can do this in the constructor. Or if it's stuff that only needs to be done, or sometimes only can be done when the game is started, because there's things you can't do in the constructor because some things don't exist yet. For example, the player controller, because there is no player before the game started. It's like the Big Bang. The player launching your game, you're seeing being loaded, and then the world coming into existence is kind of the Big Bang of this game world. And there is nothing before this. So you can't fetch the player controller in your constructor because it simply doesn't exist yet. Because in a way, the game world doesn't exist yet. Well, it does, but not completely. I know. The comparison is a bit not completely, totally super accurate, but I think you get my point. So if there's any more questions about constructors, begin play, instantiation, please don't hesitate to ask in the comments, in the chat, or the nice little hashtag you can see residing just over me. Feel free to use this on Twitter or tweet me directly, and I will see to cover your questions during the run of this series. So that is where we can place our stuff. So then we need to clean up here a bit because there's a bit of a, I like tidy code, you know. So call to bind functionality to input, we already know this. And here's a stray new line that we don't need, called every frame. We're also used to this by now. Called when the game starts or respond. We talked about can ever tick last week, why this might be important. If you set this to false, the tick function will never ever be called. And sometimes you want to do this for performance reason, because basically you always want to avoid the tick function being called if you're not doing anything in it, if it's empty. In Unity, it's enough to just delete it. In Unity, this is the update function. Well, for those of you who know, Unity. In Unity, this would just be called update. It would do the very, very, very same thing. And in Unity, you just delete the update function and you're done. It will never be called because it doesn't exist. And by not being called, it will not take up and eat valuable performance. However, the keen-eyed of you have already seen that we're calling super tick. And super is basically the way of C++ calling its parent. Because remember, we are extending the pawn class, the actor pawn class, that again extends the actor class and so forth. But we're just extending a class. We're not writing a completely new, fresh and empty class from scratch. We're extending an existing class, and this might have a tick function. Well, actually it does. And maybe there's super important things in there. So let's call it. And super is just the wording in C++ for the parent class. I think in Java it's called parent. In C#, I gotta admit I'm not exactly sure what exactly it's called in C# at the moment, but it might also be parent or something. I have no idea why they named it like this, but well, maybe the people who came to this decision don't even live anymore, because C as a language is kind of like the Latin. Oh yeah, this is a nice comparison actually. C is kind of the Latin of the computer world. What for us humans in the human world is Latin, in computer world is C, because it's not only so old, but it's the root of almost any other language. Almost. Like Latin. Not all languages have their roots in Latin. Quite a lot do. And it's the same with computer languages. Quite a lot computer languages have their roots in C. Not all of them, but quite a lot of them. We got our begin play, and we got our constructor, and this is a thing. I'm not sure if I mentioned this already. It says fill out your copyright notice in the description page of project settings. We could do this. It's project settings, and then it's right here. Right here where it says fill out your copyright notice in the project settings. You could put in anything there. You can say this is copyright in 2020 by Devcom Tutorials. Maybe I should... Actually, my previous was smaller. I have no idea if I put the hashtag as tutorial or tutorials. It doesn't matter. Use both. I'll be looking for both. I'll just be looking. I think we should better call it tutorials, because then we are consistent with everything else. Because I think any place else it's called tutorials, because there's not only one. There will be more. Yeah. So, and from now on, whenever we create a new class, this will be put there. I've now done it manually, but if I would now go into the editor and say I want a new C++ class, it would from the get-go have this comment up there. And the documents say that if this comment is missing, the compiler will abort and give you an error. I have not tried this. Maybe we just try this out tonight. But they want this. They want this. This very first line is supposed to be a copyright notice, like who is responsible for this file. And it's a project-wide setting. So unfortunately, you cannot do things like go into your project settings and say, yeah, this is Devcom Tutorials. Let me make this a bit bigger. This is Devcom Tutorials, and the author of this file is me. Unfortunately, you can't do this because this is a project-wide setting. So if you commit this to your repository and then your colleagues will pull this, they will have this exact thing in there. So when they create a new file, it will state you as the author, so they can do really bad stuff in there, and you got all the blame because you put your name in there. So this is a generic and project-wide setting, and they really want to. Maybe we try just leaving this out. Maybe the compiler really complains, but honestly, I don't think so. Okay, enough of that. We got a clean and tidy C++ class. This is the basics. Every pawn has these things. And there is pretty much no code whatsoever in there. Oh yeah, one more thing about the can ever tick. I would not recommend, excuse me, need to lubricate my throat a bit. I would not recommend setting this to false, because this can have, I had this happen and I was wondering why my component wasn't working. I'm not sure if it's the case with actors, but it's definitely the case for components. Because I did this. I deleted this and I said, because, this was what I was actually getting at. If you just delete this, this is why I was talking about the parent, the super thing so much. If you just delete this, it's not enough. The tick function is still being called because the parent function that we're extending, the aPawn class, still has a tick function. So it still can be called and it will be called. And even if there's nothing in there, it will take up valuable performance. So just deleting this will not do it. You have to actively disable the tick function being called. And I wouldn't recommend doing it this way because sometimes this will actually prevent your component from being registered and properly initialized at all. So I had this happening with a component of mine where I just set this to false because I was like, okay, this doesn't have to tick, it just holds some data. And I could clearly see the component was added to my actor, but it didn't do a thing. And I couldn't even set values, I couldn't even set properties that I had set up using the uProperty edit anywhere thing. I couldn't even see my values in the editor that I wanted to edit. And once I set this to true, everything worked again. So setting this to false might actually prevent your object, your game object or your actor or component or whatever you have. It might actually prevent it from being properly created at all. So I would recommend never setting this to false. Always leave this at true. If you do want to enable to disable the tick function being called because you don't need it, you can do it in your begin play. Here you can say there's is actor tick enabled, and you can set the, no wait, this is yeah, you can, this is the getter for it. There's something you can call to actually disable it. Let me see if I can quickly find it. Set actor tick enabled. See, sometimes the world is so easy, and thank the heavens for auto completion. This is why I don't know and why you do. I mean, you can't just remember all the APIs. You just, there is so much stuff you can call and so much stuff you want to call. You can't just remember it all. So this is why we have auto completion. And you can just say set actor tick enabled false. This basically does the same thing as setting this to false, just later in the lifetime of your object. Because remember, the begin play is called when the game starts or your actor is spawned, or your component is initialized, whatever. By the time this is called, your actor, your component, or whatever you have is already being properly created and set up and initialized. The thing already exists like you designed it. And now you can set the tick enable to false. So TLDR, this does the very same as setting this to false just later in the lifetime of your object. at a point where it does not interfere with the proper creation of the whole thing. However, we do need the tick. We will absolutely, in this case, we absolutely do need the tick. So, yeah, we're not going to be setting this to false. Just for demonstration purpose, we might just set, once everything works, like it works, how it's supposed to work, we can set this to false, and then you can see our tick function is just never called, just for demonstrating purpose. But I think you believe me when I say it works. So now there's a few things we need. Remember when we set up our blueprint actor, where is it? It's somewhere here. When we set up our blueprint pawn, remember that we added two things. We added a static mesh, in this case just the cube for an example, and we added a camera. So we actually have the perspective we need or want for the player in front of the screen to see everything. And this was quite easy because we have this neat little editor. We can say add component and we can add all the things to it. Now, if I go back into the editor and I have my C++ class here, and before I break anything, I'm just going to be saving these. So, yeah, if I do a double click on my blueprint, I get this and I can neatly add all the things. And if I go to my C++ class and I double click on it, well, it opens in the editor, in my IDE, in my C++ IDE. When I right click and I say, great, here's the edit, it opens in my C++ IDE. And when I right click it again, I clearly get the idea that I won't be able to just add components to it. And this is exactly it. This is, I mentioned before that the way I usually do it, I create my actors or pawns as a blueprint, and my C++ code lives in a component that I just slap onto the blueprint actor pretty easily. And this is exactly the reason, because adding a mesh and adding a camera are very common things. And we actually now have to code this. Remember the convenience of just saying add component, static mesh. Okay, cool. Maybe I even write it not wrong, and there we go. Static mesh, I just can add it. And it works fine. Yeah, no such thing if you do it completely, and this is what we want to do tonight. If you do it completely in C++, you actually have to add all these things using actual code, and this is what we're going to do now. Because editing your stuff in basically a glorified text editor, which our IDE is the only way to do things with your actor. So, what do we need? Let me take a look at my notes, because there's quite a lot of things we need to do. We added a static mesh and a camera. So, we want to do that. Oh, okay, and we are not even storing the camera in a thingy here. This is something public. How do we sort this? I thought we we're going to do our properties first, or our fields, whatever you want to call them, and the functions later. How to describe this? I think we need to rewind a bit. When you have an actor, when you have something that lives in the scene, in your game world, the things you see, if we do open up our blueprint actor again for a second, and I grab out the old magnifying glass, you can see there's a small but subtle distinction. Here's this divider line, and we got a default scene root component up here. I think you can read this one. This is the default scene root component. It cannot be copied, renamed, or deleted. It can be replaced by drag and drop another scene component over it. I think we need to talk about scene components for a bit, because scene components are the put easy. Scene components are the things that have a transform, things that can be at a certain rotation at a certain point in the world. So everything that is, that has a transform, like our static mesh. Our static mesh has a transform. If I set the Z value to 100, you can see our cube rising up. If I set the X value to 100, you can see our cube moving to the right. And I could just put them all back to 0. Because this is a scene component, because this thing exists as something that is in the scene. That can also be things that are invisible, like our camera. The camera also is a scene component, because the camera exists in the scene, because this is the object that's used to have the point of view from where the player is looking at. And our moving component, that thing only has some random arbitrary code that just does stuff. It's a collection of functions that eventually get called. It's not, our moving component does not really exist as something inside the scene. So when we go into the scene, we start the game. Okay, which doesn't work because we deleted our pawn. Let's put it back in there, and I don't know, let's place it just there or so. So, and now we skip out because you can, the game is still running. The game is still running the game code and the game logic, but with Shift F1 you can get your mouse back, and you can hit this little button, the little play figurine thingy, which detaches you from the player controller. So what this does is, when it's enabled, this is the default. Now you're attached to the player controller. You can do stuff where you can actually play your game. So, and even if you get your mouse back with Shift F1, you have your mouse. I can click on things. I can do things. I can reply to my mail and everything. But I can't do anything in the scene. The moment I click back into the game view part, I just control my player pawn again. So what you can do is you can detach yourself from the player controller, and then you have, while the game is running, you have all the editor controls that you're used, and you can click and select things and do stuff with them. Oh, and Dana is late. No need to be sorry. Real life always comes first. And if you're really super interested in these things, there's always the recording. And I'm super happy for you to be here at all. So, hi. A very nice... Yeah, it's evening. It's not night yet, right? It's still... yeah, it's still the sun shining out there. I actually got up quite late today to be ready and fit for tonight. So, for me, it's a bit after lunchtime or something. And it depends. I mean, this depends from where you're watching. If you're watching like from the US, it's maybe early in the morning or something. But Dana, hi there, and let me properly. I mean, that's time we just have to have. Let me properly greet you with a certain dose of, well, you know what. Cinnamon Queen, yeah. The Cinnamon Queen, that's right. So yeah, you have all the editor controls while the game is running if you detach. And I did this to show you if I click on this, we don't actually see the camera because the camera is. We could actually make the camera visible. Can I do it from? I should be able to do it from here. Oh yeah, details. This is still the world settings. I don't want world settings. I just want the details of our little thingy here. And you can see here are all the components that are added to our pawn, and here's the camera and the static mesh, and I can select the camera, and it's simply set to, let me quickly find it. It's set to, it's somewhere under rendering or stuff. Is editor only the rendering feature? No. Because there's a check mark for invisible in game, and I have no idea why I failed to find it. Oh yeah, camera mesh hidden, because for the camera it's a bit different, but it still doesn't show. Okay, well, it's set to not show in active game. Because you actually don't want to see the camera. The camera is just there so you know where you placed it and where it's looking at. It's just supposed to not show. Maybe we can set it here. Maybe a fine. There's a check mark for. Well, let's just uncheck this here. Maybe it needs to restart. Well, anyways. It's set to be. Oh, there it was. There I could just see. There it is. There. Okay. It just didn't work when I was changing the flag during the game was running. But now the camera exists because it does have its mesh around to symbolize it. But the point where I want to get it. All these things, even if it's something in our current project, I do have a couple of scene components, but they are scene components for a different reason. But they still exist. They just don't have a static mesh that is shown. They are not visible, but they exist. They do exist in the scene because they do have a transform. If I click this thingy, the camera does have its own transform, and if we just put this to 0, you see the camera does move. So yeah, TLDR, everything that has a transform, everything that can be at a point is a so-called scene component, and everything else, like our moving component down here, this one only holds code. It doesn't have a transform. It's not somewhere. It's not placed somewhere in the scene. So, and this is the distinction. This is why here's the separator and why this thing is shown a bit separate. Oh, Hobbitsbock! Hi! Hi! Ja, mir geht's sehr gut. Trying my fake accent. My fake American accent. I would actually like to have a UK accent when speaking English. I would. That's something I would need to learn. Hi Hobbitsbock, grüß dich. Hoffe, dir geht's auch gut. Bei mir ist alles super. Hi. Yeah, so, this is, I know it's not completely clear, and if you want to talk about this more, please let me know either in the comments or just here. We can talk more about scene components and normal components, code-only components. But this is very important. We need to delete this thing because we're going to be placing something else there. So we have two scene components. Was programmieren wir da? Nichts Spezielles. Im Endeffekt nur ein bisschen einfach gucken, wie es generell funktioniert. so ein bisschen allgemeines, wie funktioniert es eigentlich. Das ist jetzt kein echtes, definitives Projekt, an dem wir da arbeiten. Das machen wir nachher, das machen wir gleich in der Aftershow-Party. When we're done here, maybe this might be important for the one or the other of you. When we're done here, we're gonna be raiding over to our studio channel, and we're gonna be continuing a bit on the Spaceflower channel. And there I will actually work on our current project. This is actual code that's supposed to be played with. That doesn't exactly sound like what I want to say, but you get the point. So if you want, stick around. And later tonight, we'll be actually working on actual code that's meant for an actual game. Yes. So this was a quick excursion in scene components, that they exist and why they exist, and what's the difference to normal code-only components that just supply us some functions we can call. And we need one of these, at least. Wo ist der Alk? This is just tap water, but if you want, you can just pretend this is something else. But if you could smell it, you wouldn't smell anything. This is just tap water. The hard stuff has to wait. So we need a scene component, and in Unreal, the class name for a scene component. Well, let's see if our auto completion helps us. We know we need a scene component. Oh, and look at that. Scene component. That looks pretty good, because Unreal objects, we had this last week, are always prefixed with U, because they are based on Unreal object, on the Unreal object class, which is the base object. U object is basically an empty object the engine can work with. So it's not really empty. It has some boilerplate code, so the engine can actually handle it, and garbage collection and the whatnot. So this is why this is prefixed with a U, because this is basically a U object, and scene component sounds pretty much like what we need. And you've seen when we looked at it, it did have a root component. Let's quickly take a look. Right there. Default scene root. Because when we just created, we didn't replace this. We could, in theory, we could pull the static mesh up over the scene root, and then we would replace this default scene root component with our static mesh. Totally fine. The default scene root is just basic. It's an empty scene component that doesn't have anything, that doesn't do anything, it doesn't look like anything, it doesn't have anything that can be shown like a static mesh. It just sits there and serves as something all the other scene components can be attached to or childed under, because in Unreal, your actors that are in the scene, they always have a scene root component, and any other scene components are always child of this one, because it has to begin somewhere. Well, this is basically, instead of just having a list of scene components, you have one scene component that's a bit special, because that's the very first one, and all the other ones are just childs of that. That's just how they build it. Coat of Hearts. Yeah. So, and we need a scene root, and as we could just see. I just did it. I just pulled the static mesh over the scene root component, and now our static mesh is the root component, the root scene component of this actor, which works perfectly fine. And now instead of two childs, the static mesh and the camera, we only have one child, which is the camera, which is a child component of this thing here. What you call it? Cube, right? The thing with the 6 sides. Does it have a 6? I mean, does it really have a 6 side? I mean, we only have seen the. Yeah, it does. There's the 6th side. Not a 6th sense, but a 6th side. And that's something you can not break your tongue but your teeth with when you try to pronounce that properly. So the thing is, we do need a scene component, and we always have a root scene component. So let's just call this our actor root scene compo. Don't you laugh, auto completion? Yes, this is exactly what I want to call it. Yeah, because we do need to have that. And then we terminate this with a semicolon, and hopefully the world is a better one now, because now we don't have any errors anymore. We need this. And again, we need to manually do this because we don't have any fancy editors where we can click around and add things. We actually have to add everything by hand. So let's try to put something in there. And where do we do that? We do this the best. This is actually, now we have to decide, do we put it into the begin play or do we put it in our constructor? And we have to put this into our constructor because our pawn, our game object, needs to be completely set up and existing and have everything it's supposed to have before the game actually begins. So before the Big Bang happens, we already have to be done. I'm not sure if it worked with maybe it worked with our universe the very same way. Maybe because our universe came into existence at the time of the Big Bang, things were already being pre-created so they can exist once our universe exists. But this would be a discussion for a completely different evening. And maybe actually with some beer or something. So we have to set this up in our constructor because this has been done as early as possible. And let me just double check something. Okay, and this is actually getting, yeah, this is getting a bit even a bit more complex than you might have thought, because we got our actor root component. Root scene component. Sorry, this is when you look for an actor root component and you actually named it actor root scene component, there might be a reason why you're not actually finding what you're looking for. And now we have to put something in there. And again, these are things you can just learn them and never forget them and know them. And I would have the highest of respect of you. Well, these are things you over time you get used to them. There's things you do over and over again. So you know, okay, now I need to call this thing, now I need to call that thing. But this might be a thing that you're not calling every day, so just look up the documentation and you will come to a Unreal API call that's called create default subobject. Now that's a nice name, isn't it? I haven't myself, I have to admit, I haven't myself completely understood what create default subobject means so far. The thing is, it's a templated call, so we need to use these spiky thingies. And you give it a type. So basically a class which is our scene component. And it creates the default object, a empty default object that's based on it's some Unreal internal magic, because you can't just say if you want an object of scene component, you can't just instantiate that like you would do with any other plain C++ object. You can't even do that if you're writing a base U object. I mentioned this last week. In Unreal, we are only every type, except for very basic things like float, is replaced by a special Unreal variant. So we don't have strings, we have F strings. You have an F string object. And we're using a string now, and internally this will be an F string object. But once we come to working with strings, because, I don't know, you want to print text somewhere, you have, instead of a basic string, you have an F string object. Or instead of an array, you have an how is it called? F array, I think. Or instead of a map, you have an F map. You have always these Unreal versions of these things. And even when you're writing an empty C++ class, at least one Unreal can work with. With no, it's not an actor, it's not a something. It's just an empty class where you just put arbitrary code in. You base this, you extend the UObject class. And you can't even just instantiate this like you would do with a normal C++ class. It just doesn't work. You have to call an Unreal specific API function. I think it's just called newObject. And then you give it the type, then you give it your class. So you need to call this to instantiate it. Because in the background, Unreal, I mean, it's a game engine. It's a huge framework that does a lot of things in the background that we don't even think about, that these things might be possible or needable or required or whatever. So you can't just instantiate this. And scene components and some other objects are even more special. You can't even just instantiate them with newObject. You have to call stuff like create default subobject, because Unreal has to do a lot of things in the background to actually create an object that you can then use and that behaves like it's supposed to be. And garbage collection also is one of the things that are handled in the background there. So this is why we need to call create default subobject for a scene component. And this is basically it. This is basically the whole call. You see there is red squiggly lines there because it's not completely the whole deal. It wants one parameter, but this parameter is a very easy one. It just wants a name. Because if we take a look in the editor, you can see, or hopefully, if I magnify it a bit, you can see that all these things, and these are all things that are in the scene, like let's select this table, and it's called table. And I can call this anything else. I can say this, the shiny table in the middle. Doesn't matter. I can give this thing a name so that in the world outliner, because this is the list of everything that exists in the scene at the moment. So I can, by the name, see, wait, okay, the shiny table in the middle, I know it's this thing. Both chairs are just called chair. It's a bit hard to know which is which. I could call them right chair, left chair. So I could exactly know just by the name what it is. And that's exactly the name this function wants. So we can call this root component. Or let's call it something we can actually. Now let's stick with root component for now, because that's how I have it in my notes. And if I mess that up, I get totally confused, and then I explode, and I don't want to explode because I want to drink at least one more vanilla cinnamon cappuccino tonight, and I can't do this once I exploded. And this brings us to another thing. There's so many things. There's so many things when it comes to coding in or for Unreal. Because while this is a string, and technically this is about correct, it's not the preferred, it's not the absolutely completely correct way of doing it. We need to do something else. We need to call a macro that's just called text. And this is something that goes for every single text string you ever gonna be using anywhere in your code, surrounded with the text macro. Und der Wilde, hello there, a wonderful evening to the white one. You always have, and this has reasons that are for localization. When this is very easy. This is just it's not even only American characters. It's just ASCII text, But you could, I don't know, we could put something like this in there. And then things might break because if it's just a plain, because this would be a plain and simple C++ string. And in C, there is no such thing as a string. In other programming languages, you actually have a primitive type string. Primitive types are the smallest types we have, like integers, floats, Boolean, and whatever. And in most languages, if not in almost all, you also have a primitive type of string. You just can't say, yeah, in this variable, there's a string in there, there's the text, and everything's fine. C or C++ they don't know strings. A string for C is an array of characters. Because when you look at it in memory, and we'll be talking a bit more about this when we finally come to talking about pointers. This is just a few random characters that are somewhere in all the gigabytes of memory your computer has. And by chance, they are just sitting next to each other. So this, for C, this is not a string. This is an array of single characters that's located somewhere in memory. And again, in Unreal, we're not really using the normal types. We always use the special Unreal versions. And of course, there's a special Unreal version of the string. I think I already mentioned this, which is an f-string object. Now, how do we get a proper f-string object? What I could do is I could just create an f-string object here. I could go like f-string the name. But then again, if I set this to something, if I then want to set this to some string, I could do it this way again and maybe not mistype even the easiest of words. But again, this you see, the squiggly lines only tell me there's maybe declaration assignment can be joined. Okay, this is something completely unrelated. Unreal really wants text to be in a bit more special way, so Unreal actually can, well, do all the magic in the background. And TLDR is very easy. We have a macro that Unreal supplies us. This is called text. You just say text, bracket open, your string, bracket close, and that's it. And there we have, now we have a completely Unreal compliant textual representation of what we ever put in here. And this goes for everyone. Every string, every string you ever use anywhere, unless it's, I don't know, if you have a map and your index type is string, then you don't have to use this. But if this is any text that's supposed to be used anywhere in the engine or in the game, put the text macro around it. Again, if you have a map, for those who do C#, it's what dictionaries are in C#. But I think C# also has maps, but let's not get completely confused by that. If you have a map and your index type is string, you don't have to use this. Then you can just use your raw strings because you're just using this internally to index your map. It's not supposed to be displayed anywhere, usually. If it is, then use the text macro. So, but now it still complains. It's a no operator matches argument. Oh yeah, because, haha, and I always this is something I got used to, because this is something I quite often get wrong, and this is why I immediately know what the fix is, because it tells us, not sure if you can read this, it tells us no operator equal matches arguments type of uScene component and uScene component, and you see that little asterisk there. Well, it even tells us perfectly what's wrong, because create default subobject, if I can get the message back again, returns a uScene component with an asterisk at the end. And remember last week when we talked about, and here they come again, pointers. Because this doesn't, because I explained this last week, so if you missed that and you have no idea why this is and everything, you might want to rewatch the session from last week, or just wait till we make the dedicated session about pointers. Because in C, we can't get whole objects into a variable. We always get the pointer, like, you know what, that thing you're looking for, it's over there. And we are only getting the it's over there part. But I defined this as this is the whole thing. So how do we fix this? Quite easy. I just say this isn't the whole thing. This is just the there it is part. And if I now go back into my code and I maybe save everything, you see the red squiggly line goes away and everything's perfectly fine. So in actor root scene component, this is our variable name, we now have a usable object that is just an empty, well, I don't want to say random, an arbitrary. It's just an empty arbitrary scene component object that we gave the name of root scene component. This is also one of the things create default subobject does. It also takes care that if this thing is displayed anywhere in the editor, that it knows what its name is. So, what can we do with our actor component? And I'm currently looking at something else because we also need... oh, wait. This is not the root component. This is our actor root component, right? This is our actor root component. Let's not get this confused. This is quite confusing stuff, so please bear with me. that I have to peek into my own notes. But looking up at your own stuff doesn't count as cheating. So cheers to the non-cheaters. We also need a camera, right? Because we need a camera for two reasons. One reason is because we had one before, so we want one now too. And the second is, of course, we need a camera because we need our player to seeing everything from the proper direction. Because when we don't have anything, right? Okay, if I don't have any defined player cameras or any cameras that I'm switching the view to, and I just hit play, I'm getting the editor. Well, kind of. I'm getting a default thingy with a default camera. I can just move around, but this is maybe not what we want. Not only maybe, this is definitely absolutely not what we want. So we need a camera. And let's see if there's something like a camera component, because that's what we added. Remember when we did our that thing there in the blueprint, when we added a camera, we basically added a camera component, because everything that we add to our actor is a component, just like in Unity. Oh, Psychoshade is raiding with a lot of viewers, and even the Grieved is there. Hi there. Greetings go out to all the nice people from Psychoshade, and I know that you're coming. Aren't you coming from the? Didn't you do the gamescom stream? Didn't I think it was your gamescom stream tonight? Oh, and even Amy's there. Hi there. Greetings to you all, you lovely people. Your timing is perfect because we did the thing from the done. Exactly. And now we're doing the done from the thing from the whatchamacallit. Because we're going to need a camera. And we need a camera component. Maybe there's something like that. Cine camera component, close but not quite. Oh, look at that. There's a U camera component. The U, again, tells us, okay, this is an Unreal object. So we're not completely wrong there. Yeah, the Gamescom supports small streamers stream. Yeah. We support small coders here. U camera component. And let's just not do that one mistake where I was missing the asterisk, because since we made the mistake once here, we know we're only getting it's over there part. We're not getting the whole camera, we're just getting the pointy thing, like the camera's over there. So, camera component, and yeah, of course, we need to give this a name, and we just call this our camera. So, and again, this is create default sub object, and because I'm so lazy, I'm just going to be copy pasting this from down here. And again, this is U camera component. I just love the way the auto completion in this IDE works. And we also just give this a name. And again, we use the text macro to make it a proper text string like Unreal loves them. And this is our pawns camera. Pawn camera. Camera and pawn. Oh, there's a pun. There's I'm pretty sure there's a pun in there. Pawn Cameron or something. Nah, I need to think about that. All right, so now we have an empty scene component and we have a camera. So much for that. This is just our camera on DS. Yeah. Oh, camera on DS. That's good. That's pretty good. Where do you want the camera to be pointing? I want the camera on the ass. Oh, that's a good one. That's a good one. So, first, let's add a few comments here. Let's say create our camera and the scene root component whatchamacallit. So, dark red rose. Ooh, that goes deep, that name. The dark red rose. Hi. You're coming from Psycho Shade. That's good. Hi there. And thanks for sticking with us. And again, on the off chance of repeating myself, welcome. Always wanted to learn coding for Unreal Engine, but as a 3D artist, you know nothing about C++. Well, then I got good and bad news for you. The bad news is this tutorial series is actually about C++. So while we're doing a bit in not C++, and this is ending up in the good news I have for you, we're doing mostly C++. At least we're going to be talking a lot about C++. But Unreal has something exactly for you. If you're the artist of the team and you have no idea about, at least no idea about C++ coding, Unreal Engine has these things called Blueprint. And they look like this. And they're super nice, especially for people who have no idea about the classic way of coding, by which I mean like you do it in C++, line by line by line by line. Because in Blueprints, as you can see, it's kind of like, and I don't mean this bad. I mean this in the best way possible. It's kind of like Lego. Because you have all your little thingies and whatchamacallits, and you just put them together so they do what you want them to do. So even without any coding knowledge or coding experience, you can get stuff done in Unreal Engine. And even if I wouldn't recommend it, I absolutely would not recommend doing it. But in theory, you can make a whole game just with blueprints. Because maybe with only very little, very special exceptions, you can pretty much everything that you can do with C++ code, you can do with blueprints. So you can do your complete game in blueprints. And me personally, I love when it comes together of blueprints and C++ code working together, which we are doing here, because this set movement is a C++ function we have written ourselves in our own C++ code, and we're just calling it from a blueprint. So in an actual project where you're the artist and you do have a coder, it's just not you, some guy else, the coder can actually work his magic in his C++ code, and he can give you the ability to just call it if you need to. And this is, I think, one of the huge strengths and what I really like about Unreal Engine. When you make blueprints and C++ just work together. When you have the coder who does his code stuff, and then you got the artist. In our team, this is actually the case. If you have enough time and if you want to stick around for the after show party, which happens on our studio Twitch channel that I'll be raiding when we're done here, I will actually be working a bit on our actual project. And if you want, I can, or if anyone wants, I can show stuff there. And there we have exactly this case. I'm the coder, I write my C++ code, I love my C++ code, I'm happy. And our artist then just uses this code by having a blueprint node that he just draws this pin to, like, okay, do this. Whatever it does, do it. Or for the game tiles in our game, where he just sets a few tags and the code will know what to do with all this stuff. Amy will need someone's help someday. Do you mean you? Because then absolutely no problem. But if not, then I don't know. But this might have been directed to someone else. I blue no more. Yes. And Dark Red Rose already used some very simple scripting blueprints, nothing major, just a little bit at least. Yeah, but I mean, that's how you get started. This is exactly how you get started. You just do a little bit, and then you feel comfortable because that works. You know how that works. You know how you have to do this. And then you do a bit more, and another bit more. And after you have done quite many bits more, you have done something great. And once you've done it in blueprints, and once you've done it a lot in blueprints, and this is why at the beginning, for those who stuck around from the beginning, where what we are now doing in code, we first actually did in blueprint. So we have an idea of what we do, because most of the things work exactly the same in C++. You just have to write them a bit differently. So once you're good at coding in blueprints, the step to C is not that much of a big one. So who lives close to who? I don't live close to you guys, I think. Since the stuff is over, we should meet for a coffee. Absolutely. Once the COVID stuff is somewhat contained, we definitely... there's so many people I have to meet again, especially from the town I used to live before I moved where I'm now. There's so many people, and many of you we will definitely have to meet. Absolutely. So, but let's go on with this. So we get this maybe somehow working tonight. Maybe we can put in a bit overtime. We created our camera and the scene root component, because remember, we do need to have a scene root component that's sitting somewhere. And now we actually need to bring these things together. We need to attach our camera and visible object to our root component. Yeah, let's do one thing more. Let's make an actual dummy root, because this might actually not end up our root component. Not sure why I called it like that. Let's create an actual. Yeah. Create an actual root scene component to put everything to attach everything to. To attach everything to, and of course this is like that. So again, wait, let me just peek a bit. Why did I, how did I? See, this is when you got confused with your own notes. Then you know you should check your notes a bit more often. Because where's my root component? And why are my glasses getting all foggy right now? Where did I define this thing? Okay, now I'm completely lost. Now I somehow clicked the wrong button. Oh, okay. Because See, this is the things you don't have to know. You just have to, because our object, we're in a pawn, we're in an actor pawn. We already have a root it already has a property for the root component, and we just have to put one in there. So we can just use this one and say this is the actual root component. So this is just our actor component. I'm too lazy to rename the whole variable here. Just bear with me. Yeah. Because this, and this was the part that just got me confused a bit, because we never defined this anywhere. We don't have this in our header file, because this is actually defined in the pawn itself. Maybe if we click into the pawn, or maybe it's even in the actor. Well, let's not go down that rabbit hole. This is a property of our class that exists because we are inheriting from all that stuff we're inheriting from, and we just need to have a scene because this thing is empty. As I said before, if we do this in C++, we have to do everything by foot with our bare hands, everything ourselves. So by default, this thing is empty. There isn't even an empty scene component object. This is just, there's just nothing in there. Ref Roadpest, same to you. Have a wonderful evening. Thanks for sticking with me for so long, and see you around. So we first have to fill our root component with an actual object, which we're doing there. And then we can continue. Now, we attach everything to everything. Jesus Christ. I should practice more typing. So we got, what have we got? We got our camera, and we got the thing that we called actor root scene component for whatever reason. Maybe because we weren't thinking and stuff came to mind a little bit later. So there's a few things, and I don't think anybody would expect you to just know this unless you've done this so many times you just do. But if you just look up the documentation, you will very, very easy find this. If you Google for how to set up an actor in C++, you'll get all the references, because we have our camera. This is this one. And we have to set up the attachment. There. Set up attachment. And we have to tell it to where we want to attach it. And of course, we want to attach this to our rot component. Yeah, our rotten component. All right. To our root component. Remember, back in the blueprint, right here, we have our okay, well, by now we replaced our default scene root component we had here. We replaced this with the static mesh. Remember that first we had the default scene root component and then we had everything beneath. This is exactly the way we're replicating this in the code right now. And this is our root component, and then everything is attached to that. So this also goes for the camera. And then we have to put the camera somewhere. This is kind of intuitive because we know the camera is somewhere, but remember, scene components are things that are somewhere with some, they have a transform. So we do a set relative location. There's an interesting distinction also. We got set relative location and set world location. If we do set world location, I mean they are quite self-explanatory. If we do the set world location, this is the position of the camera in our game world. Like if we set this to 0, 0, and 0 for all 3 axes, it's right in the middle of our game world, which might not be what we want to do, because we want to be the camera being relative to our pawn, because we want the camera to be looking at our pawn. You might want this differently, depends on your game. You actually might want a static camera that's sitting somewhere, and then your pawn moves, but maybe the camera doesn't. But we don't want that right now. So we set relative location, and such a location is quite easy. It's an F vector. Again, it's not just a vector, it's an F vector. I have yet to find out what the F stands for. Like the U is for Unreal Object. The A is because it's something that's derived from an actor. I have yet to find out what the F stands for. I don't know. Maybe some of you know. If some of you know what the F in all these, F types, because you also have F map and F array and everything. If some of you know what the F stands for, then please do tell. And we put this at -500, 0, and I think positive 500, right? And positive 500. That's a nice position. This is basically the very same thing we did when we set up our camera in our actual blueprint. You know, this thing, when I added it, it started here, and then I moved it a bit to there, I moved it a bit to there, and then it was just looking straight. It wasn't looking at my whatever I got there. It was looking into a completely different direction. So we also have to set the rotation. Things that we just conveniently set here in the editor, we now have to do, as I promised you, all by ourselves. So we also have a set relative rotation. Great, and we could give this an F rotator, and me peeking to the side is actually looking at my notes, so I know what to put in there, because to have it properly rotated, we put this at -45 degrees, and then just zeros. Which interestingly is, we gotta see what I think the camera is also at a different position. Because in our blueprint we had a slightly different rotation. We had the rotation in the y-axis, but well, let's see what this gives us. Maybe the numbers are wrong, and then we just can change them. Now we also got our actor root scene component. That's a long name, so I'm just going to be copying this over. And we also have to attach this. Like we attached our camera to our root component so that it exists. We also have to, because if we don't do the attachment thing, they don't exist. I mean, we can't comment out, just for demonstration purposes. We can't comment out these attachments once it works, once we know this properly works, because we do have our camera object, we do have our actor component, and this is the thing that we'll actually see, which in our blueprint is the cube. And I think here I might make it a cube, maybe we make it a sphere. Let's see if we do have a sphere, or maybe we could make it a chair. We have objects created for these things, but just because we have these objects created doesn't do anything. We actually have to put them onto our pawn. It's like you have a very nice house built of Legos, and now you got the light brick. You have the light brick that makes it all shiny and really looking nice at night when the lights are off, because that light brick will then be on. Just having it doesn't do anything to your house. You actually have to put the light brick somewhere in your Lego house so it actually illuminates your house. And this is very much the same thing here. We have our camera, we have our visible component that can be seen, but yeah, they're just there. And now we have to attach them to our pawn, and this is the setup attachment. And this is why we had to put something into the root component here. We could try, depending on how much time we have left, we will try this tonight. Otherwise, we will try this next week. We could try to omit this and putting this one directly as our root component. That would be maybe a nice optimization we could do. So we will be basically they are doing the same thing. Are they supposed to do the same thing? Oh, haha, no, they are not supposed to do the same thing. But still, we could exchange them. But I did do something wrong here. Maybe some of you noticed already. Yeah, but we're going to try that. So let's continue. I just noticed something being wrong because I'm just creating a scene component here. Having a scene component up here is okay, because remember when we had it in the blueprint, there was just the default scene component. It was empty, didn't have anything. And this is exactly the thing. If you were asking yourself, why you create another scene component? That thing has nothing, that thing is empty, you can't see this. Then you're asking the right question. Because this is not supposed to be a scene component. Remember what we did when we created our pawn in blueprints? We added a static mesh component. A static mesh component is a scene component, but a extended kind of scene component where you can select a static mesh so it actually looks like something. So I'm very sorry about this, but we have to make this. This happens when you do it live and not pre-edited for YouTube. I'm also very sorry for all the guys on YouTube that are watching this video and are thinking, why is this guy talking so much? Why doesn't he just show us the interesting things? This is a live stream, and live streams work a bit different than just pre-read. Now, okay, I should stop talking and typing at the same time. I want a static mesh component, and there it is, static mesh component. And now my IDE will complain, or it should, because I'm trying to put a static mesh component into a variable that I have defined as a scene component, which shouldn't really work, right? So let's correct this. So yeah, this is the challenges of doing this live. You can't just say, oh yeah, screw that, rewind, let's try this again. Is this going to be a third-person game? This is actually, right now, this is not going to be anything. This is just demonstrating how things are done. But the thing I'm currently building here will be a third-person cube. Yes, you will be able to move a shiny cube that will look like this in a third-person view. Exactly. But for now, we're not actually building something here. This is just for demonstration purposes on how you would do it if you would actually do it. If you want to see an actual project, I will do this right after this stream. I will switch over to our studio Twitch channel, to our Spaceflower channel. I will also rate you guys from here over to there. So if you want to stick, you don't have to do anything, and you can come over with me, and we'll having a little after show party where we can talk about random stuff. And there I will actually work a bit on an actual project, because there I will work a bit on our game that we're currently trying to build. And yeah, this will then be not just for demonstration. This will be an actual project, actual code that is supposed to eventually be played with, or causing someone to play a hopefully nice game. So if you're interested in that, yeah, just stick with me and we'll be getting there. So, what's missing? Do we have anything? The first thing is we should maybe have our pawn getting visible at all. And just to save you guys some time, there's one thing that's missing, because we're just creating in this line, we're just creating a static mesh component. We're not putting any static mesh in there. We're not selecting the static mesh that's supposed to be defined, because we didn't do this here as well. We created our static mesh component, and then we went over here and said, yeah, I want to use the cube. We need to be able to do this for our C++ pawn as well. So this needs to be visible in the editor, so we can actually set the static mesh. So we need to prefix this with, you might already know, uProperty, edit anywhere, and this should do it. Let's try to compile this, and in a perfect world where everything works, we should be able to pull this actor into the scene and select a static mesh for it to actually look like something. So let's hit the favorite button of everyone, this little Borg cube over there that initiates the compiling. For a C++ tutorial series, we did quite little compiling tonight. I shall do better next week. Next week, we're going to be doing more compiling. So, compile complete. So we didn't put any too huge errors in there. Or if we did, they will just make the whole thing crash. Yeah, that happens. So, and now we're doing something really nice, because this is our C++ class. This is, let's magnify this a bit. This is our CPP pawn. This is a C++ class. And now let's just drag this class into the scene. And there you go. Now you have your C++ class sitting in the middle of the scene. Is that cool? I personally find this quite cool. That you just write your class, you just drag your C++ class into the scene, and there it is. And now we should have, oh, look at that. Actor root scene component. Did we call it like that? I think this is actually this is not the name we gave it. This is the name of the object, interestingly. I have to check what's with the name we actually gave it. And here's our root component. See, this is exactly, there's our root component that we created, just empty. This thing has nothing. And stuck to this is our actor root scene component. This is the thing. This is the thing we just called it a bit strangely. Interestingly, I don't see the camera here, because I think the camera is somehow attached. It doesn't show up. I don't know why. It's weird. Sometimes you just don't have to understand it. But here's our static mesh, and we can also make this a cube. Oh, materials. Oh, it's a material. Shape cone, shape cube. Here, there it is. We can also make this a cube. So now we have a neat little cube pawn sitting in the middle of our scene that we have made in C++. And it was quite more work than doing in blueprints, because instead of just adding something and selecting something, you have to write everything in code. Speaking of code, let's put some more code in, but code we already kind of know. So our movement. let me see. Okay, this is, let me just copy paste this in because this is something we've already done. So we can just add this. In our tick function, we do something like this. Apply our movement. Here's our movement vector again. I need to lubricate my throat a bit more. Oh yeah, that's quite lubricated. Here we have our movement vector again. We had this before when we just did it in the component. So this is quite easy. This should be well known by now because we've done that. We've talked about that. Let me just... where's the header file matching to this one? And this is a vector. And this doesn't have to be visible from the outside. So we just make this private. This is our thing. No one has to touch our movement vector. And if I save all this, it shouldn't be read anymore. So if the movement vector is not 0, we create a new location, which is getActorLocation. Quite self-explanatory. This again is a Unreal function that is just available to you to get the count location where your actor is. And since the pawn is just an actor, you know, we don't need you get pawn location because the pawn is an actor. This is basically a level down. And we add our movement vector to it, but we multiply our movement vector with our delta time. Yeah, remember, we are frame rate independent. And then we just set the new location and be good with it. Now comes one more important and interesting thing, because we gotta set our movement vector somehow. For now, just to see if it works. And I would have almost said, okay, come on, let's set this from the blueprint like we did before, but we can't because we don't have any blueprint. We don't have any blueprint involved with this. All we have is, well, not this single file because the header kind of comes along with it, but all we have is this little piece of code. So just to make sure it works, in the begin play function, we're gonna be setting our movement vector. And this is basically what we did from the blueprint, where we had our set movement. You remember with our set movement function, and we called it just with, I don't know, some values. So set movement value X is 1, and these are floats. So let's make it properly. And then we have Y and Y not, and these are not, because in British English zeros are called not. Not sure if you knew that, but in British English you could pronounce this as not. Yeah, I don't know, I just thought that was funny. So it should move in the X direction. Because we just set it here, and here we see if it's not 0, and then it moves. If this now moves, if this works, we apply the movement, which isn't that much more complicated as well, because there's, again, things Unreal just offers you. You just have to know it, how you get to the axis values, and if you don't know it, find someone you can ask or just look it up in the documentation or the internet. Again, you don't have to know everything, you just have to know where you can look it up. So, compile. And I hope this works, because I have this said many times before, and I'm afraid, I think I will say this many, many more times, but the hot reload is broken since quite some versions of Unreal. So sometimes you have to restart the whole editor, the whole engine, for your compiled stuff to work. But if I click on this, nothing happens. Okay. It happens. There's even way less stuff happening than I thought would happen. I was expecting a bit more, because it's moving not at all. Can we find out why it's not moving? We're setting the movement vector here, and we're checking if it's 0, and I suppose it's not. And oh wait, maybe it is moving. Maybe it is moving, but it's moving really slow, because it's moving 1 unit per second. And 1 unit is, in this case, not even a pixel. Or maybe the hot reload didn't work. I don't know. But yeah, you can see it. The movement does work. You just can't see it. You can see it if you look at the numbers. If you look at the number, you can actually see that thing's moving. It's just that it's moving so slow. Oops, that was the wrong button, or well, it was not enough buttons. Oh, and there's our. I think this is the camera that goes with our actor. Yeah, it is. Look at that. When we move it up and down, there's our camera. Still not sure why we don't see it in the component list. But we do have it here. Maybe the camera is just the component handles itself a bit differently, and it just doesn't show up. You could say it's a no-show, but then again, it shows us something. We're just not seeing what it shows us when we hit play, but that might be because we didn't possess the actor yet. Maybe we should do that, because we did not remember when we did it in the blueprint, we had to possess the pawn with the player controller of our player. So we of course have to do this here as well. And we do this, and this is actually this is a bit more easy than it was in our blueprint. Remember, in the blueprint we had to get the current player controller, and then we had to call the possess function. Or we can do this here as well. But what we can do here as well is just say auto possesses player. This is again this is a property of the class. This is a property that we have because we're inheriting from the default pawn. And we can just say to, you automatically receive input from player 0. Let's see how that works. Compile, and hopefully it manages to properly reload everything. Okay, camera still doesn't show. But that might be a problem for another day. Can we actually maybe... Oh yeah, there you can see how it moves. Can you see it? Well, it moves so slowly. So let's just put our movement speed in there, which is this is our class. So there's our movement vector, and can I just wait a minute? We don't have a movement speed yet, right? Let's make one. Oops. Let's make a movement speed. We know we want this to be editable from the editor, so we just add this one, and this is a floaty movement speed, and we default this to 100 because that has worked rather well for us in the past, and we just multiply this in here as well. Movement speed, does that work? Can I just multiply a vector by something else? Should work, because it just multiplies all of them. Nice. And let's try that. Compiling, simply compiling. Yeah, and we're compiling. And we're finished compiling. And here we go. Look at that. Where is it? Oh, there. Look how fast that moves. Isn't that nice? It moves so nicely. How nice is that it moves? Okay, let's get the player input in there, because I promised you we're going to be doing that today. And for player input, remember we had our axes defined. And remember that I also told you that this setup player input component thingy here will become quite important, and we are exactly at the point where this becomes important, because this is where we set what axis we actually want to use and to react to. So we got input component, which is the input component. We don't have to take care about creating this, create default sub-object, all the yada, yada, yada. This is already done for us. Unreal has already created us an input component, and now we just have to tell it what we want to do with it. So we could say bind axis, or remember, we could, when we were in the project settings in the input area, we could say we can define actions like jump, shoot, or we could define axes where we like move, constant value, like when you have your analog stick. This is why you could also do the movement by action button, because you could say, you could action D, and then you can increase or decrease your location like you want it. But if we do it with axes, and when later on we stick a game controller on my computer, we could just add the game controller to this axis definition as another possible axis input. And then you can actually have analog. Maybe we should do that. I should see that I get a controller connected to this thing for next week. And then we can see the difference, why I did this as an axis. Because if you do it as an axis, you also can handle the analog values of the analog sticks of a controller. So we did an axis, and I think we called one of them vertical. I hope, because there's no auto completion here, because that was just an arbitrary name we entered there. And then we have to tell it. This is basically like in the blueprint where we told it for which pawn. Remember when we said possess, and we had to tell it which pawn it's supposed to possess? And we just gave it a reference to ourselves. Well, we can do this in C++ even more easy. We just say this. And now we give it a function that it calls every time Unreal feels like it wants to let us know. And we call this how are we going to call this? We call this vertical axis. That's a good name, right? We call this vertical axis. So we don't have something. We don't have a method, a function with that name. So let's just create one. And if we would look at the documentation or my cheaty notes, we would know that we get a float value. And we can just call this axis value. You can call this whatever you want. You could even call this Schnitzelsalat, and it would be perfectly fine and work. The thing is, you just get the value passed with this one parameter. And then let's do this for horizontal as well. Horizontal. So we also need this here. Horizontal. And of course, this is the horizontal axis. So these are still red, and these are also red. There's quite some things here. There's actually two things that are wrong with this. These have red squiggly lines under them because remember, every function we have in our class has to be defined in the header, which we didn't do yet. Thankfully, we have an IDE that makes life for lazy people like me super easy. So I can just say, please do create this declaration for me. And if I would have called this function independence, it would be a declaration of independence. You may laugh now. So, and here they are. So this is our header file, and you see it just added these two to the public block, which is perfectly fine because they have to be called from the outside. Then again, we might try making these private because since we are passing pointers to them, it shouldn't really matter if they're public or private, but that is something we need to just try. Okay, and these work now. Maybe not, but this won't work. For some reason, we need to put, well, maybe this, yeah, I think these might become purple in a bit, because this is still not super duper 100 completely right. Remember when we talked about passing values back to blueprints, and we talked about passing something by reference? Because what we do not want to do here is to call this function and return its return value. It doesn't return anything anyways. But we want this to be called from someplace else. So we have to pass a reference. And a reference is always a pointer. So look at that. The good old asterisk is back. And I don't think it works. Oh, it might actually. It might actually just work like this. Not sure if it's completely necessary to include the class name. Just for completeness sake, we do this for now. Another thing we can try out to just omit this. It might actually still work. But for now, I do know this definitely should work. So we're passing a reference, a pointer, to this function. So the input component can then, since this is an axis, they are called every frame. Like the tick function, this one. This is called every frame. And these ones, since they're axes, and this is one of the major differences between axes and actions. The axes are updated every frame. Every frame, this input component will call the method we're giving it here, we're pointing it to here. So we always know the value of those axes to where we need to move. If this would be an action, it would only called when the button is pressed. And when the button is not pressed, nothing's called. These are also called when you do nothing. When you're just sitting there, your game's running, you don't even have your controller in your hands. You're just watching Netflix. These are still called, just with the value of 0, because, well, nothing happens. So now we have to process this. This is very easy. I mean, this is our axis value. So we can just put this into our movement vector, right? We can just say our movement vector, is it x? I don't know. Is just the value we got there. And since I'm so lazy, I'm just going to be copied because I mean it's basically the same. All we do is we store the value we get here. Oh, and this is not exactly the same. This is y. See, this is y. There's a pun in there. a good one. I just have to find it. So these are called every frame, and they are because we told it so. You can also unbind. You can also, there should be an unbind axis somewhere. Okay, maybe I confused it with all the other stuff I have there. But there should also be an unbind. Well, you can do it. I'm not exactly sure how it's called. Maybe it's just called a bit differently. I would have to look that up. But you can do it. You can unbind them. So, because this, of course, this might eat some performance. If these are called every frame, and you're getting in a situation where you are like, yeah, I don't need this information right now for whatever reason, you can unbind them, and then they are not going to be called anymore, and they'll be saving you some performance unless you bind them again. Because in general, you should avoid doing stuff every frame unless it's absolutely necessary. And this is also the reason why maybe jump you would do as an action, because you only would need to be notified about the spacebar for jump, maybe if it's the spacebar. You only need this to be called when this event actually happens. So yeah, this is the difference between axis and actions again. And if everything goes well, and I don't forget to compile it, it might work. I forgot to remove the set. I forgot to remove, where is it? This one, in the begin play, where I just set it to some static value that just moves. It shouldn't hurt us, because since every frame it's updated by those values, this has basically no effect. Well, let's see. Let's hit the play button, and it still moves. It still moves. Because for some reason we have not possessed it. This is interesting. Why did we not? Maybe if we put this out again, compile it. We haven't possessed it yet. Maybe I should find the default player pawn thingy. Maybe we need to set this as the default pawn. So I should take a look at it again. So we just pull this in again. Select a nice mesh. Our cube again. There it is. I don't know. Put it somewhere where it looks nice. Oh, interesting. The camera doesn't update. Well, here you see what the camera of the pawn sees, and quite interesting. Camera doesn't update. Oh, now it updates. And now it works. Oh, look at that. Okay. Sometimes it just works if you delete and re-add stuff. Because I think what happened was, remember all these things we do here. One moment, please. Okay, need to refill. All these things we did here for auto possess and all the yada yada yada. We did so in the constructor, and this is the difference between the constructor and the begin play. We did this in the constructor, and in the editor. Wow, okay, this is funny. The handle being so much out there. Do we see it? Oh yeah, and there's the camera again. Cool. Yeah, and now it also updates. Oh, and the handle is because I set it. Remember, look where I set it. I set our visible thingy, our static mesh component. No, it was our camera I set to someplace else. I didn't set this to someplace else. Nah, maybe this is just a glitch. I don't know. It's for now, it's okay. Well, it does have a strange position. Okay, for some reason this our oh no, wait, this is the whole actor. This is our, yeah, but this does have a quite strange position as well. I don't know. Maybe I accidentally. I think I know. Okay, I know what happened. I accidentally see, and I think I just did it again. Yes, I just did it again. I didn't move the actor. I moved the cube inside our actor. So I actually have to select our root thingy up there. And this is also why before the camera didn't move with me. See, sometimes when you give it a second thought, things actually make sense. Again, okay. A quick why it didn't work before. I had the old instance still here. And I mean, we're recompiling stuff while it's actually running. But it still had an instance of our pawn based on the old code in the editor. And this is why this thing still moved by its own, why the camera didn't work. Because all these things that we did here to make this work, they weren't executed because the object wasn't recreated. It still was there. And this is only called when the object is created. And since it still was there and we kind of reused it, it still worked. What would have also worked would have been completely quitting and exiting the editor and restarting it. That would have worked as well. But deleting our pawn and just re-adding it also created a new instance. So yeah, this is what just happened and why deleting and re-adding it. This is the reason why that worked, in case you're interested. And in case you're not, you might be happy that YouTube has a fast forward button or something. So, yeah, now we can click play. And look at that. There we have our nice little cube. And when I now hit my keys on the keyboard, it's moving and it's kind of slow. But we can change that because we made this value so we can set it. I just have where's our movement speed? It has to be, where's our movement speed? Where's my here's our pawn and it should have a movement speed. There it is. Here's our movement speed when I now set this to 250. And I reprocess everything, then it's quite a bit faster. And I can actually move our neat little cube with my keyboard, and this is basically now my playable character that I can do nice and funny things with. And as promised, we did this completely in C++. There's absolutely no blueprinting involved like last week. The whole thing is just this little C++ class, just to demonstrate again. Here's our class, click on it, it just opens it in the text editor. It's just a bunch of text. There's some commands, we can actually delete this. And as promised, this is a complete controllable player pawn. You can run. You can move the thing with your keyboard. And I see that next week I do have a controller, a gamepad. So we can actually also implement controller input for this. And it's only done in pure C++. No blueprints, no safety nets. There's so much that can go wrong. There's so much you have to do yourself. So because it's already that late and we're basically, well, this is timing, isn't it? This is perfect timing. This was what I wanted to do with you guys tonight. And we're out of time. We're at the end, and this is exactly what we did. Just for a quick comparison, when we did our blueprint pawn, it was super easy. We just created a new blueprint. And we added a static mesh component that we said, okay, please look like a cube. We added a camera that we just moved around a bit, and we gave it an angle so it actually looks at the cube. And we were basically done, at least with this part. We did have to add a bit of this, but this part, adding the camera, adding the cube, super easy. And then when we wanted to do this in code, in pure C++ code, we had to do this all by our own. Every button we clicked, like the add component, we actually had to code and say, okay, look, I want to add a camera. I want to add something like this, and I have no idea why these texts don't show up, but I'll be finding out. Well, and there they are. So, Ro says, looking forward to the Big Bang Beer event. Oh, yes. Oh, yes. Alrighty. You're really looking forward to episode 3. Very glad to hear that. Hope we will not hear for long. No. Okay. Revenge of the C++. Yeah, it will come. It will come. I'm pretty sure that we will encounter the one or the other absolute total crash when the pointer goes rogue, but and this is actually something I do want to show you, because there's ways to find out where it crashes, how it crashes. There's because you can actually debug it. There's a debugger, and that's pretty cool, and something I definitely want to show this. So we will be seeing crashes, and be they forced on purpose, manually, or whatever. So this was doing, oops, wrong window. This was doing all of these. Oh, I closed it again. Maybe I shouldn't be so quick with closing my tabs. So this was adding things like these that in blueprints are super easy, doing them in code, because every button you push, every add component, camera, you have to manually do this in code. You have to write a line where you create the camera object, and then you have to manually, you still have to attach it, and the position, you have to set it in code and everything. And this is the reason why when I work on actual projects, I usually create my code, my C++ code lives in a component. Usually not a scene component. Sometimes if it has to, yes, but usually just a normal actor component, like we did last week. And my actors and pawns are actually based off blueprints. They are blueprint because there I have, it's so convenient just saying, I want a static mesh here, I want a static mesh there. If you want to stick around for the after show party, I can show you something, because the actors that make the game tiles in our current project, doing those all in code would have been so much work, because there's so many components. There's so many static mesh components. There's other scene components that are actually self-made C++ code. And I just added them in the editor, and doing it in C++, you can do it if you really want. As much as you can do in an Unreal Engine game completely in blueprints without any C++, you also can do an Unreal Engine game completely in C++ without any blueprint. But it makes your life so much, well, maybe not harder, but definitely quite some more uncomfortable. Well, not comfortable. It's inconvenient. Inconvenient. This is it. That's it makes your life so much more inconvenient. because for every tidbit you have to do, you have to code it, and not just, oh yeah, I move this a bit over there. Nah, yeah, you have to do all these things. All right. If there are any pressing questions, then please ask them now. Or if you're watching this on YouTube, put them in the comments. Or if, no matter when you're watching and where you're watching this, and you're on Twitter, tweet on Twitter. Up there's the hashtag, just over me. You can also do Ask Devcom Tutorials. I think up there it's it's missing the S. Both works. I will create a saved search, or saved search, not safe search, on Twitter. I will be on the lookout for those hashtags. And should you have any questions, please feel free to tweet them at those, or tweet them directly at me, the Real Hellcat, or tweet them at our studio, SpaceflowerDE. And if they fit into what we're talking about here in this tutorial series, I will see that we cover it here. And if not, I will just answer you on Twitter or in the YouTube comment or whatever. All right. So now let me push a few buttons because, as mentioned quite a few times already tonight, we'll be hopping over to our studio channel right now. And if you do want to stick with us, you don't have to do anything. Just sit there and enjoy the show, because I will be raiding this channel over to our studio channel. Let me just prepare this. And now I have to do a quite funny thing, because now I have to start a second stream. And I hope this works. I tried this. I really tried this 2 days ago, and it worked like a charm. I just hope it will do so as well now. So if everything worked, the Spaceflower stream should go live now. And if it does, I will. Yes, it does. Oh, and yes. I can already. Oh, and I can already be heard on the Spaceflower channel. So I will let the the outro play for the tutorial session. I just have to find it because I closed my modules. It's that one. Yeah. Okay. I will let you play the outro, and right after the outro, I will engage the raid over to our other channel, and there we will be sitting and talking about random stuff. I will be working a bit on our actual project, and DK Jens. Hi. Your timing is impeccable. You're coming perfectly right for the raid. But I'm kind of raiding myself, because I'll be raiding over to our studio channel right now. Well, you can stay with us. I'm not gone yet. We will actually continue. We will just continue on the different channel, where we can also talk in German if you like. We can't talk in French because I totally can't do French. And where I'll be working a bit on our actual project and not just on demonstration stuff. And we can talk a bit about stuff. I can show you stuff. I can answer questions if you have any. So if you want, stay with me. And in a minute or so, we will be seeing us on the other channel. You don't have to do anything, because I'll be raiding this channel over to the other one. And I will just have the outro running, and right after the outro, it'll be over at the other channel. So, oh, where's the, oh, there's the button. Okay, it was barely seeable. All right, see you over at the other channel. If I don't see you, which would make me very sad, then maybe next week, or on Twitter, or whatever. And have a nice week.